For the last few decades, Earth has had an interesting coincidence. The northern and southern hemispheres have reflected almost the exact same amount of sunlight back into space. But new data from NASA shows that this balance is breaking. The planet is becoming uneven in a way we have not measured before. Why is this happening? And will it change the weather we depend on? Well, let's talk about that. If you tear a map in half at the equator, you get two very different pieces. The northern hemisphere is the crowded side, with about 68% of Earth's land. It has huge continents of North America, Europe, and Asia, the sands of the Sahara, and the snows of the Himalayas. The southern hemisphere is the total opposite. It is a water world. Besides Antarctica and a slice of South America, it is almost completely a deep, dark ocean. In fact, there is a spot in the South Pacific where you can travel for thousands of miles without touching a single piece of land. This area is home to the oceanic pole of inaccessibility, better known as Point Nemo. It is so remote that if you sailed there, the nearest humans would not be in Chile or New Zealand. They would often be the astronauts on the International Space Station passing overhead. It is one of the emptiest places on Earth, surrounded by thousands of miles of open ocean. Now, when sunlight travels 93 million miles and hits Earth, two things can happen. It either bounces off the planet and escapes to space, or it gets absorbed. That is because of something called albedo. It works just like what you wear on a super hot day. Lighter surfaces act like mirrors, bouncing the sun away to help keep you cool. Darker surfaces are like sponges. They soak up that energy and turn it into heat. Now, humans have actually used this idea on a smaller scale. If you did not know, many traditional houses on the Greek islands are painted bright white. It is like a kind of ancient air conditioning. The white paint reflects the strong Mediterranean sun and helps keep the inside cool. Cities are now trying a similar trick. Places like Los Angeles have spent millions of dollars covering black asphalt streets with a special gray surface to raise the city's albedo. By making the ground a lighter color, street surfaces can cool by about 15 degrees. Now, on a much bigger scale, even a planetary one, ice, snow, and bright deserts act like mirrors, bouncing back the light, while oceans do the opposite. They soak up the rays and store that energy as heat. So, according to physics, the land-heavy north should reflect more sunlight. The ocean-heavy south should absorb more. Meanwhile, when looking at Earth from space, one half should look brighter than the other. So for decades, NASA has tracked Earth's energy using a system called CERES, short for Clouds and the Earth's Radiant Energy System. These satellites measure how much sunlight arrives and how much leaves. This is how we learned that Earth is breaking the albedo rule. Now, think of Earth's atmosphere as a giant planetary mixer, always moving heat between the north and south so it does not pile up in one place. According to the latest data, that mixer is starting to fall behind. When scientists looked closely at the CERES data, they saw a clear split forming between the hemispheres. The northern hemisphere is now holding on to more of the sun's energy than the southern hemisphere. Specifically, the north is gaining about 0.3 watts per square foot per decade more solar energy than the south. Yep, that sounds tiny. But multiply that by every square foot of Earth's surface, and you have a huge engine of heat that could make the weather unpredictable. Now, you would expect clouds to fight back by reflecting more heat to space. But the data shows that the response has not been strong enough. So the extra energy keeps building up in the northern hemisphere. Now, this is a big deal because heat is what makes weather move. Hot air rises and pushes wind and storms around the globe. If one side of the planet makes more pressure than the other, those wind patterns have to shift. So, it is not just that the weather is getting hotter, it is that the weather physically moves to new places. You have probably heard of the geographic equator, the invisible line around the middle of the planet. But there is another equator that is connected to weather. It is called the thermal equator. Think of this as a big collision zone. Imagine aiming two powerful fans at each other. Where the air streams meet, the air often gets forced upward, creating what can look like a moving wall of rain. Scientists call this zone the Intertropical Convergence Zone, or ITCZ. It marks the planet's thermal equator. Sailors had a better name and knew it as the doldrums. They knew it as a place where winds cancel each other out. Pirates in the 1700s were scared of it. You could get stuck there for weeks, just floating, waiting for your drinking water to run out. The system acts like a planetary thermostat. It likes to stay where the heat is. For most of human history, it stayed right in the middle. But if this imbalance keeps growing, it could slowly push the thermal equator north over time. Now, you might be thinking, so what if the rain belt moves a few hundred miles? Well, history gives us a pretty striking example. About 6,000 years ago, this rain belt sat farther north than it does today. At that time, much of what we now call the Sahara was not desert at all. It supported lakes, grasslands, wildlife like hippos and giraffes, and thriving human communities. Rock art from the region even shows boats and swimming scenes. As Earth's orbit slowly changed, the rain belt moved south. Over time, rainfall faded, lakes dried up, and the landscape turned into the Sahara we know today. The trigger was different, but the process was the same. When the planet's energy balance shifts, the thermal equator moves, and the rain moves with it. This is a huge deal because rain is incredibly important for food production. It waters the regions that grow our coffee, our chocolate, not our chocolate, yep, and the crops that billions of people eat. If that belt follows the heat and moves north, the rain goes with it. The jungles in the south could dry out, while cities in the north could get hit with floods they were never built to handle. But the air is only half the story. Down at lower elevations, the extra heat starts a chain reaction. Remember the t-shirt example? Much of the northern hemisphere depends on bright snow and sea ice to reflect sunlight away. But as temperatures rise, that low-altitude ice melts. When the white surface disappears, it reveals darker ocean water or bare ground underneath. This creates what scientists call a feedback loop. As the ice melts, it reveals the darker ocean or land underneath, and that dark surface absorbs more heat, which can cause even more ice to melt. It is a cycle that could make it harder and harder for the region to cool itself down naturally. Meanwhile, the oceans respond more slowly. Global currents act like a giant conveyor belt, moving warm water around the globe to balance energy. But this system is delicate. It only works when the water's temperature and saltiness are just right. When the north holds on to too much heat, it throws the currents off. And if the belt slows or breaks, the effects do not happen overnight. They unfold gradually over decades or even centuries. But finally, is this just a temporary glitch, or is Earth settling into a brand new pattern? Right now, scientists cannot tell for sure. Maybe the clouds will finally show up and fix the balance. Maybe the oceans will move the heat around and save the day. But if the north keeps gaining an energy advantage, the weather maps we rely on might change for decades or centuries. If that happens, many places will have to rethink their daily life. Places not used to rain would suddenly feel cheated, while the value of raincoats, umbrellas, and white t-shirts would skyrocket. That's it for today. So hey, if you satisfied your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright.